Before starting this, this when I sent the abstract for the talk, it was called "Don't Fear the Storm," and the talk was going to be about like the internals of FlowStorm, ClojureStorm, and all the internals of it, plus a couple of demos in the end about the new stuff in FlowStorm 4. But as I started building the talk and the slides, and also taking a look at my previous talk here, like which is called Refined Execution, I get here on the Clojurians, London Clojurian meetup, I figured out that I was going to repeat myself a lot because things haven't changed that much internally. So I had to kind of change my agenda a little bit. So yeah, I also changed the title. Now it's going to be like the power of the storm, and the agenda is going to be a little bit different. So yeah, so we still are going to go over like the storm's refresher, like what is FlowStorm. This talk assumes that you know a little bit of FlowStorm, but anyways, we are going to go a little over what is FlowStorm, the big picture, how things work internally, what about instrumentation and recording. But then we are going to jump into demos, like a lot of demos, like features, workflow tips and tricks, basically how I want to show how I use it on different projects, different situations, from web applications to like how I use it to approach a new code base I'm not familiar with. Then I'm going to demo also the outputs panel, which is something new on FlowStorm 4. Talk a little bit about accessing recording from the REPL, and then to present data windows, which are new in a way of visualizing data, which is new in FlowStorm 4. So yeah, let's jump into this. So FlowStorm, what it is, it's a dev tool. It's a dev tool about recording programs execution into flows and also visualizing data. Today, FlowStorm, it's about those things, but mainly the main difference with other tools, it's about recording programs execution. A flow here, it's a track of recording of all threads activities. So you can think of like a software that lets you push a button, like I want to record this, you execute whatever, it's your web application, something from the REPL, you record all threads activities, and then get a way of looking at this. So you basically record each thread as they are running into a timeline, and optionally you also record like a total order timeline if you are interested in thread interleaving and all this stuff. After you have all these recordings, FlowStorm is going to provide many tools, from like graphical tools and also REPL APIs to explore those recordings, to try to figure out how things work. It's meant to be used interactively, like most things in this, like your REPL there. It's basically for understanding systems. So it's not only for debugging, it's not only for chasing bugs. It is for understanding system at different levels, like from a function to an entire code execution. Yeah, so the big picture of FlowStorm can run in various modes, but when we run it in like in-process mode, which is called local mode, everything from the UI to like your code and everything runs on the same JVM. And it's basically composed of 3 parts. So you are going to run your code, whatever it is. It's called instrumented code because this code will be a little bit modified, so it will generate traces as it runs. Then we are going to record all those traces. And after we have all those recordings, we can analyze them from the user interface or via the REPL programmatically. We organize the recordings in flows, and they are composed of 1 timeline per thread. Plus, these timelines are basically arrays. You can think of them as arrays of events. And then we have this total order timeline here, which is like how the timelines interleave. Okay. It can also work in remote mode, which means that you are going to have like your instrumented code and your recordings, all this stuff in one process. That allows this thing to be, for example, on a remote JVM across the internet, or on a browser, or in Node.js, while using the FlowStorm UI or the REPL API, which is going to run on the JVM and connect remotely via and REPL and WebSockets. So this is like the big picture remote. Next, we are going to take a look a little bit in more detail about what is this instrumented code, how it works. And so FlowStorm has a couple of ways of instrumenting code. We are only going to see one, which is the more ergonomic one, the most used one currently, which is called ClojureStorm. So what is ClojureStorm? It is a project. The thing is, like, currently the official Clojure compiler doesn't have any instrumentation related stuff. So it's good for compiling things, but then you cannot hook into it so it can trace what your code is doing. So ClojureStorm is a fork and tracks the official Clojure compiler. It enhances it with instrumentation, so it's going to emit extra bytecode. It's decoupled from FlowStorm. I want to mention this also because it's a project that's not, it's decoupled from FlowStorm, so you can use it on your own project. It will provide instrumentation controls and hooks, and it's currently being used by other applications like Clofidence, and which is about test coverage and Dynasty. So yeah, I also want to note here that there is also ClojureScriptStorm, which does the same thing for ClojureScript. So it's a ClojureScript compiler fork. Yeah. So a little bit more about instrumentation. Don't worry about the bytecode here, reading bytecode or anything. So what the Clojure compiler does is it grabs a Clojure expression and it emits bytecode. It basically emits a class with on methods and bytecode. So this is when you run the official Clojure compiler on this little function here, which is at edge, that's going to just like add a keyword to a map with some ears. The official Clojure compiler is going to emit the bytecode here in black, okay? And when you use ClojureStorm, you will have exactly the same thing, but with more bytecode instructions in green here. As you can see, the new instructions are going to call some trace functions where you can hook into them. And for example, if we look at this thing here, which is basically the normal Clojure compiler will emit something for putting the M parameter, the M expression on the stack. What ClojureStorm is going to do, it's going to duplicate that and then call that trace expression function with a copy of that pointer together with some source code coordinates. So we know where that value, that reference, how it relates to source code, okay? Yeah. And how's FlowStorm going to record? So FlowStorm basically it's going to listen to all these trace calls, okay? And so it's going to hook into ClojureStorm. And as your system runs, it's going to store all those events, all those function calls and expressions that are there. All events and intermediate objects reference, so the garbage collector doesn't collect them, and it's going to store them with a pointer to source code coordinates. So after we have the recordings, we have pointers to the values and also like where they came from in relation to the source code. And all this can be done because of immutability. So because if you try to record any something like a pointer to a mutable map, for example, it doesn't make any sense. You are not recording anything because as times goes on, that map could change and then you don't have anything. Immutability gives us by just retaining the pointers, you're already pointing to a snapshot in memory. Yeah. So things as FlowStorm receives these traces, these events, it's store them in what's it's called thread timelines, one per thread, and it's basically an array of events. So you record like time flows this way. You record there is a function call, now an expression execution, another function call, and then a function return, or the function throw an exception and stuff like that. And there is also, as I said before, we record like a total order timeline. If these are thread timelines, so all the events per thread, there's also another array, which is optional, that will point to how these interleave. So this is useful when you are like trying to figure it out, race conditions and stuff like that. Okay, so and that's all for the refresher. My idea now is to jump into some demos, future workflow tips and tricks. And before starting, the demos here assume some basic FlowStorm knowledge, so that these demos are not going to be tutorials. There is some material, that there is the user guide. The FlowStorm UI includes tutorials accessible from the UI there. And so, yeah, it's, and also the idea here on these demos is you don't need to focus on the details, but more focus on the flow, on how like how I can use like different features to try to figure out different things, or how they can be useful, even if you don't understand like the exact details of the application I'm demoing. Okay, so with that said, yeah, I will start with web apps demo. Okay, I hope you can see my Emacs screen there, and the font is right. So what I have here, it is a Clojure REPL, like a Clojure instance, a JVM running with a very little project. It's just for demo purposes, but it is a web application, this to-dos app here, where you can add new to-dos, mark things as done, and it's just a server-side render thing. There's no JavaScript or anything going on here. So yeah, this is already, the server is already running there. You can refresh that. Okay. So what I do when I start working on my REPL, when I first start my REPL, I will just start FlowStorm. First time is gonna take a little bit. Let me make the font bigger here. Okay. And then I will just send it to the background. Okay, so I normally work with the FlowStorm on the background, and recording is off, so it's not doing anything. So you can go and do your REPL stuff, try your things, do everything. Whenever I need to check for something, like for example, well, I want to try to understand like what happened when I load the home page here. So I will hit the record button, and I will just do the thing, like call something from the REPL or whatever. Okay, and after that you can stop your recording or keep it recording, doesn't matter. After you have your recordings, well, you have many tools to explore what happened, from like single stepping and trying to see how it goes into like rendering and all that stuff and executing. This web application is also storing things in a SQL database. That's why you see like JDBC stuff there. But you have all the tools for looking it from a tree perspective, or from a function execution perspective and all that. But here I'm going to demo things like, for example, you can click on a request here, and you can already see like the contents of the request. You can explore it. But something I always do with some web applications is sometimes the request, some special request is hard to generate because you need to go to a flow to get that special request. So I will record that request, and once I have the request, what we can do is we can name it. I'm going to call it R from request, and after I give it a name, I have it here on my REPL. Because I didn't namespace it, it's going to be as user R. And but now I can, for example, I can call my application handler. Since in Clojure the handlers of web applications are just functions of the request, you can call them. And this is nice because now I don't need to go to the browser to do these flows there, to these workflows. Now I can just go and manipulate my code and reval and then come here and just retry the request without having to do anything with my web application. This also applies, of course, to any other kind of application. Yeah. Then other things I normally use is once I have the recording. Sometimes I'm looking at, for example, something like this homepage render, and I would like to know, like, for example, this buy milk, where this is coming from in, I don't know, what pieces of code are manipulating it, where this is coming from the database, how is this being rendered into HTML or whatever. So you can use, for example, the search functionality for that. Search allows to search over recordings. So if you just put buy milk there, you're going to see like all the pieces of code that has that works with buy milk. And yeah, you can then double click on any of them and jump exactly to that point in time where, for example, this here, it's the to-do map that has to do with it's doing some of the update here. If you move, I don't know, forward, it's here is part of like the thing building hiccup for that specific buy milk thing and stuff like that. So and now because even like Next.js is also instrumented for this example, you can even like, I don't know, if you look at the first time buy milk appears, it's going to be deep inside Next.js, resolves it on some, I don't know, something. So you can go super deep into like where this is coming from, how it's being manipulated. Yeah. Another thing I want to show here, because I use it pretty often on web applications, it's printers. So printers are a way of like defining print statements, but instead of defining them on your code, like when you wrap something on a print statement because you want to see like every time that piece of code is called or stuff like that, you can do that, but without even modifying your code. And you can rerun the print statements over your recording. So you can click something like the request, for example, just right click here, add to print. And I don't know, I can do handling, for example. And if I leave it like this, I'm going to be printing the entire request map. But yeah, I don't want to see the entire request map. I just want to see, I don't know, the URI of it. So there's a way of transforming that. And after you have that, you can come here to printers and you can run the printers, and you can already see that, yeah, our software has handled like the root and the favicon request. But you can go further into this by, for example, I don't know, if I jump into execute all from the Next.js. This is because I already know it, but I found a little place here on the function that executes all the statements. So I will add like a printer here, like these are the statements and these are the parameters. So I will grab this expression and I will add a print here, SQL statement, and I will add another print here. I don't know, like to print, and I will call this SQL params, something like that. And if I rerun this, I'm going to see that, well, when something is hitting our root, we are doing a select after from to-dos and without any parameters. But after we have that defined, if we keep recording, we can keep, for example, I don't know, I will mark this as done, for example. And now if I refresh this, we are going to see that now we are handling markdown, and then there was a SQL statement update with done1 where ID was 1. The difference, another big difference with print statements, it's that these print statements are interactive. So what you can do after you have them is you can jump into that point in time. So if I want to jump into like this statement in particular, it's going to move the system to that point in time where, or for example, this thing here, where I can then, for example, look at the stack. So it's easy to see, okay, this is something inside Next.jDBC, but it's coming from mark to do done, and I can go there and jump and look into, okay, I'm running an JDBC execute with this database connection and this to-do ID. So I think all this is pretty handy. Yeah. Let's stop this thing. Okay, so then there is one more thing I can show here, is that's something pretty new on data windows we're going to see after. Is if you have any piece of code like an, I don't know, render main page. If you have you have any expression that returns HTML, for example, now you can see it as a string, but you can also see it as HTML if you want, which is, it's nice. It's not super useful here because it's rendering the entire page. But if you have like systems where you have like small pieces of HTML, you don't need to look at them where you're trying to understand the thing. You don't need to look at them like this. So yeah. Okay. So next thing. Okay. So now I'm going to show you like ways of going from your editors to recordings and back. What I mean by this, it's sometimes you are looking at your editor at some piece of code. I don't know. You're looking at here at this. This build to do item, and you're wondering there how this work. You want to step over it, so you have ways of jumping into that. One way is by, for example, using the quick jump. So if you know the name of the function, you can type it here, like for example, build to do item, and jump there, and now you're here, and now you very quickly can see what's the return value of this if or stuff like that. What's the value of done or text, and you can move around from that point in time. There is another way. This is also new, which let's clear the recording here, which is like the JavaScript debugger statement. If I don't know if people is aware, but JavaScript you can use something like this. So if I add this statement, this is gonna act like a breakpoint. That is what means gonna, like, you can run your code, but you have a very fast way of positioning your UI in that particular point in time. So now if I reevaluate this thing, just this function, and I record the thing, like now I'm going to just reload the main page, whatever. It's gonna take me there super fast. Okay, so that's a way of going. So if I'm looking at something here, I want to be there pretty fast. There are other ways, like looking, like if I want to see, for example, some instance of this call, you can come here to the functions list and look for that. For example, it's going to be build to do item, whatever, this one. Because you see it was called 3 times, sometimes was called with call the doctor buy milk. And if I want to go exactly to the point in time where buy milk was being processed, I just double click there, and now we are here. And we are at that position in time where we are generating HTML for this particular instance. Okay, so that's how fast ways of going from something you're looking into here on the debugger. Yeah. We have the other way now. Now we are looking at the recordings and we want to go into the editor. So we are looking into something here and we're gonna bring it somehow to our editor, our repo. So one function that works for this is the defining the bar as we did already for the request. So you can click anything here and do the def and put a name on it and stuff like that. But there is another way, which I think is nice, which is to bring all the context back to the editor. For example, if we are in this context here, where ID is 2, buy milk, and done is true, we can come here, right-click, and do define all frame bars. What that thing does, it is gonna define all this for us. So now if we evaluate things on the REPL, now our things here have a value, a global value bound to them in this namespace, which allows us to, for example, come here and even like try small pieces of code without having to, having to try the entire thing, and without having to do to use like some library, like scope capture, or come up here and do a def on each of those values and stuff like that. So I think that's interesting. And also another way of going from the recordings to your editor, it's, for example, like this. I don't know, if you're looking at a piece of code here inside JDBC or whatever, and you're interested in going to this thing, you can right click here, do open in editor, and this is gonna open the library for us and stuff like that. So we can have here and maybe modify next JDBC or stuff like that. Yeah, so that's another way of coming from recordings to editor. Okay, what else? Okay, I think that's all for the web demo. So I guess we can get rid of that. Okay, now I'll jump to another demo. Again, I'm gonna go pretty fast here, so don't waste much time on the details. But I want to show how I approach normally some new code base. Some days ago, like a lot of people probably have been looking into CoreAsync Flow, which is part of the CoreAsync library, and it's code that Rich Hickey has been lately working on. I guess that's why everybody was looking into it. And I was trying to make a little example. And then after the example worked, I was also interested in looking inside the code base and how it did all that magic. Before going into that, because probably not many people, I don't know, not everybody is familiar with how this, what's the purpose even of this library, I can comment on a little bit. So yeah, CoreAsync, the library allows us to create these processes and channels and connect them and do the stuff. But this new namespace, the Flow namespace, allows us to express all these things as data. So it allows us to create a graph saying like, I want to have these processes that are going to communicate with these other processes here via these channels, and you wire everything up. And then the namespace will create everything for you with instance, your channels for doing that, will create your threads. You don't need to create your threads by hand. It's going to wire everything, and it's also manage the life cycle, like start the system, stop the entire thing, stuff like that. So I created a small example here, which is a small channel which will receive numbers, any number, and then a little process here, like this little box, that it's only even. So this will receive numbers from that channel, we read from that channel, and if it's that number is even, it's gonna post a message on the only evens channel, and also keep tracks of how many events, numbers it's found so far. So it has little state there. And yeah, it then will publish messages on like events found so far 42, and I just found this new event like 2. And then I have another process, which is printer, which accepts things, and it's gonna print whatever comes into the things channel. So this explanation, it's just I think it's, I don't know, an opportunity to explain this library. But the thing I'm gonna look at, we're not even gonna run this, but I'm gonna show you. Let's say I'm interested in, I don't know, like understanding this library. So this library starts by you call the create flow with your processes and your channels and stuff like that. So let me start an instance. This is a different project, so I'll start an instance of the debugger here. And let me again the font a little bit. Okay. So without FlowStorm, what I did before was like, if I want to try to understand this create flow, I will come here and dig into with my editor, and I will come here and I will say, okay, this is calling create flow again. But once you reach here, the thing is that because Clojure is dynamically typed, sometimes it's hard to figure out, like, I don't know how these reduce work, because I don't even know what prox is about. I need to trace it back and try to figure out the shape it has, and that makes like understanding a code base much harder. So what I do now, I will just hit recording, create the flow, which will like record everything as we were doing on the previous thing. But now, whenever I'm into like, again, reading static code, I can come up here and say, well, I'm interested in create flow, this one, and this should take me there. But now I can use it next to my static code reading to see what these procs are about, what are their shapes. I can dig into them, explore them in different ways, try to see what this reduced key value returns or stuff like that. So it's aiding our code reading here. And I think it's aiding it with much more than types, because types are nice because they let you know like what kind of things it's procs, but this lets us like really see what things procs are, and even like bring them back to our REPL and stuff like that. So yeah, after creating the flow, the library, you create a graph, and then the library lets us manage the life cycle of all this stuff. So when now I'm interested in starting, for example, the graph, because one thing is the creation, the other thing is like, let's start the system. What I normally do here, it's I could use, for example, I want to keep these recordings because maybe I want to come back into this. So I will just choose another flow and I will record in a different track. So I'm not going to lose all this stuff. So I hit recording again, and then I just start my system. And you see the flow 1 here. So now we have 2 recordings, a flow 0 and flow 1. We can stop recording now. And yeah, now it's interesting because this also helps us learn about a code base, because now we can see like just running the start spawned 3 threads. If you look at flow 0, it was just 1 thread, and it's like it's not that spawned 3 threads, but there was activity on 3 threads. And if you know your example, for example, you can already kind of guess that the first thread is like our normal REPL thread, but we are starting 2 processes, so maybe they are related to that process. There are ways of looking like an overview of when you have multiple threads. I always go to the multi-thread timeline browser, which shows me like how all the expressions interleave in all the threads with different colors. But what I normally do is I filter by only functions, and then by making things nicer here, like expanding the function names and maybe the thread names. We can see here like the 3 threads, what function has been called, so it's a little bit higher level. And yeah, then we can, if we are interested in any of this part, we can see here, for example, that both threads, like the thread in this little green and the thread in this like gray thing, start after a call of featureize. So it's the main thread starting 2 features or something like that. But we can, if we are interested into what is the system doing with those, we can, for example, like double click on one of those threads and, I don't know, start stepping there like crazy. And for example, a little bit hard to do with this font. Here, for example, we can already know that this thread, it's we found like a process ID, only events, so we can kind of guess that it has to do with starting this process in particular. So that maybe helps. We can keep moving forward. I'm just clicking. And the last recording we have here, for example, it's on a sync read on a control channel. So this is a channel and it's waiting there. So that's already teaching us something. Another thing that teaches us is like, for example, this I didn't knew the first time I used the library, that the status, when you start the system, like every process starts in pause. And starting the posted status, and it keeps waiting there, blocking, it's waiting for a control message. So another thing I normally do is when I find some interesting points, I will add bookmarks. Like for example, only events process waiting for a command, or pause waiting from a command or something like that. And as I go over like different threads, I start collecting these bookmarks. You can see the bookmarks here, and so now I'll, for example, I don't know, go to the end of this other thread there, and again click to the end, and I'm seeing the same thing. So this is probably the other. I can click back. This is probably the other process being started. Yeah, this is the printer process that also gets there blocked. So I can add another bookmark here if I want. And then I can say, okay, it looks like everything starts in a posted state. So I will go and you need to resume the graph, because by default, everything starts stopping. But since all this stuff is interactive, we can test our assumption. So my assumption is like if I run now the resume, then this thread is going to be unblocked from here because it's going to receive something on the control channel, and then we'll proceed doing whatever the job needs to do. So we can try that. So if we look at this count here, so we have like this is the timeline size. We have 15 steps, and now let's just run the resume thing, and now we have 81 steps, so we can step further. And now, okay, we have like this got a reading from the channel. We can look at the preview here and say, okay, this is a flow command, a flow resume, and we can keep clicking, and now it's going into handle command. We can maybe add some bookmarks here. Okay, there's an interesting transition matrix here that shows us how you go from stop into exit or resume into running and all the stuff. Or we can click, for example, I guess we can do it with this other thread also, to the end, and now we are blocked again. But this is interesting. Now we are blocked as at reading two channels. So whatever comes first in any of those channels, we are waiting there. So I will assume, let's say I know a little bit more about this code base, and I will assume, like, for example, this now is probably, since it's this process here, it's now probably waiting for some input or some control. Okay, so that's my assumption. How can I see if my assumptions are right? So, well, I can see here, for example, like one channel is like the thing ending on 320. We can come here to the REPL and let's stop. We don't need recording. And we can see here, so we can see here like the inputs channel is the thing that ends up on 320. So that makes sense. And what is the other channel? Because it's waiting on two channels. It's, if I have to guess, of course, it's probably the other one, the first one, is the control channel. So it can receive inputs or it can receive like control, like post yourself or something. But we can check our assumptions. For example, we can click on this channel, what we think it's the control channel, and then we can go search for all the instances with the search tool again, all the instances that are manipulating this channel somehow. So we are going to the data window search. This allows us to search for values in any data window. This is called a data window. We are gonna go into this a little bit further in the presentation. This is called the data window with ID flow1 thread 65. So we can select that flow1 thread 65, and we can search for them. And we have all the instances here. So if we double click this, it's gonna take us to one of the instances. This has been used, and we can already see, like, yeah, this was the same as the control channel. If we go to another thread ID, it's probably the instance where is where are we? Here. So yeah, it's this is the thread that created the channel. So yeah, we can see that, and with that we can maybe test some of our assumptions. Okay. So yeah, I think that was all for this figuring out a code base demo. So I guess we can clear this thing and continue. Yeah, so now I'm just going to mention this because we don't have like this is going to take a lot of time to go deep into this, but how, like, recordings, everything we have recorded there can also be accessed from the REPL, and it's pretty straightforward. It's just one function. You do like get timeline with a thread ID, and yeah, with that you get like a sequence of events, and then you can use all your Clojure normal Clojure functions with that sequence. You can like take 3 from there, or make them immutable maps, and it's gonna make all the traces like an immutable map. So you can write software that analyze that data, that search for specific situations and stuff like that. I just want to mention this. We're not going to demo this. And okay, next thing I want to demo, it's the outputs panel. This is pretty straightforward, but it's new on FlowStorm 4. I'm going to use a different code base for this. So let's start, as always, the debugger here. In this is another different project. Things a little bigger. Okay, and this doesn't require any recording or anything. It's this output panel here. What it is about is just like a replacement for me for your normal like REPL console. So whatever expressions you evaluate on your REPL, you are going to automatically see there. If you evaluate like more stuff, you are going to see the latest one automatically, but you can also have like come back to previous evals. So in that sense, it's the same as using like all these variables that Clojure provide automatically, but you have like an infinite set of them, and you are just one click away. Also, if you tap something without configuring anything, you tap something and you get the tabs here, and you can explore the tabs, or you can explore your evaluations, and you are one click away of them. Or if something gets printed to the console, you are also going to have it here where you can copy and paste it and stuff like that. So it's basically that, which I think it's better than the normal REPL, because you will have like immediately a reference here that you can define. You can also use all the data windows navigation system. But yeah, that is the outputs panel, the new outputs panel. Okay. Slideshow here. Okay, so now the last part of the presentation, it's about a new feature called data windows. It came up in FlowStorm 4. And data windows are a system for data inspection and visualization. It's kind of like Portal, Morse, Reveal, all these tools we already have. They are amazing. But why another? So another one, because it has like some pretty specific goals. I wanted a way to navigate nested structures in a lazy way. So if I have like a 5 gigabyte map, very nested with a lot of, I don't know, like a lot of pieces inside, I want to be able to navigate it very quickly. So I don't want it to take forever because the tool is trying to print the entire thing or do that. I also want to support like infinite sequences. So it's part of my value I'm looking at, has infinite sequences inside. I wanted to provide a way of like with pagination or whatever to give me things on demand. I also wanted multiple visualizations for each value, and also tools for the user to add custom visualizations on the fly without having to restart your REPLs if you want to represent your values in a special way. I wanted like Clojure data file navigation out of the box. Also a mechanism for like changing real-time data visualization. So not only like static data, but when you have like when you're games or something, when you have like some numbers changing very fast or whatever, I want to have ways of like visualizing them changing in real time and stuff like that. And you also wanted like great integration with the rest of FlowStorm. So that's why there are data windows. Now we're going into another demo of data windows. So yeah, data windows are everywhere on FlowStorm. So whenever you are like stepping into something in a process, or here, for example, this is a data window on the output panel. Data windows has an ID. This is called the outputs. So you can, in case you want to access them programmatically and stuff like that, you can do. How it works, for example, yeah, we evaluate something, we have something there. The data window tells us that this is a Java-lang string. It provides multiple ways of visualizing it. You can visualize it at HTML, which doesn't make a lot of sense here, or as a seekable, and you can see it's composed of little charts where you can like click on them and see the charts, and you can navigate forward and backwards into nested data structure. You can also, like, for example, if we evaluate this is a map containing a keyword with an infinite set of odd numbers, and it works. So you can come here, and if you want to inspect this, it's gonna give you like a pagination thing where you can access like the first 200, but then you ask for more, and it's gonna realize more for you. And so you have ways of working with infinite stuff, and it also allows us to go over deeply nested data structure. It supports metadata. For example, here we can go into this thing, and we already see that this contains meta. Everything that contains meta, we can see it there, and we can click on meta, and now we are digging into the metadata, and we can go back by following the breadcrumbs back. So yeah, that is the basics. And again, we have like multiple visualizations we are gonna see next. Now, about custom visualizations, I guess we can get rid of this. About custom visualization, let's say we are like working on something that's modeling a chessboard. So we now have a chessboard here, which is, I don't know, we decided to model it like a set of chess pieces. And yeah, we can see it as a set here, but it could be nice if we can provide our custom ways of visualizing it. Okay, so without going into details, because these things are documented on the user's guide, you need to provide a way of grabbing something like data5, like Clojure data5 that will extract data from a value. We are going to do this with registered data aspect extractor here, and then you need to provide a function to render it using Java effects. Okay, we are not going into the details here, but the thing is, like, if I provide that, okay, as soon as I have my chessboard here, now there is a new visualizer here, so I can visualize it as a chessboard, like a proper chessboard. So in case you are like debugging your chess game or whatever, it's going to be much easier to visualize than maybe the normal preview or stuff like that. We can also like make it the default, so whenever like a value shows on FlowStorm, automatically it's going to use that representation. Okay, so then I also wanted Clojure data5 and nav out of the box. So this hasn't been used a lot, but I think I haven't seen it in a lot of libraries. But there are libraries that provide it. For example, DataScript, which is a graph database. It's provided out of the box. So, for example, I will define a very small DataScript database, and I will put like some persons with some pointers to other person that person likes, something very simple. But now, if I'm here on Clojure and I just retrieve this entity from the database, I'll just be seeing this, okay? But here, because it's automatically doing like the data5 thing, it's already showing me that the entire entity, but it's also showing me some arrows here, which means that DataScript, if you require this namespace, it needs to be required because it's optional, it will be adding navigation, the navigation system to your entities. So now the tools allows us to say, okay, this person likes these two other person, I can follow that. Okay, these two other person, 2 and 3, I can follow number 3, and now I'm on number 3, and I can like keep following the graph without having to do anything on my code, and I can navigate back and all that stuff. So we can do exactly the same with Next.jdbc. Next.jdbc provides out of the box Clojure navigation. It's based on foreign keys. So I have a very little example here with an H2 SQL database. I'm going to get a reference to this database. And it has two tables, like a person that points to an address for containing emails, and an address contains the email and the email name, stuff like that. I have like some random rich hickey stuff. So if I run a query like select after from person without doing anything, it's going to return rich hickey here like one row. But if I click here, because now Richiki has an address and it has a foreign key, Next.js automatically puts navigation stuff so I can go and follow into that address. And now I'm in the address entity, and I have done all that stuff without doing anything, just by using the navigation out of the box. Okay. There are some, FlowStorm already provides a bunch of visualizations. For example, numbers, you can automatically see them in like in decimal, hexadecimal, binary format, and octal. And if you're, for example, dealing with byte arrays, you can see the byte arrays like as a sequence and stuff like that. But you can also, for example, if you're interested if you're working with byte arrays and you're interested in looking at them in like binary form, you have visualizations for looking at the head and the tail of those, like, which are normally interesting when we are dealing with binary stuff. But you can provide your own visualizations on top of that. Okay. Next included visualization system, it's the EQL queries. So here I have some random nested data structure. It doesn't matter, but it even contains it models like some persons with having houses and vehicles and trips, and it has some infinite cycles inside, just to show that it also supports infinite sequences. And yeah, we normally, when we are like dealing with this kind of data, if we have a lot of data, it's sometimes we want to dig into like using this by digging into the data structures or looking them like a preview like this. But we have like an EQL printer here, which allows us to make query to try to understand our data. For example, you can, because this is a collection of things that have name, I can ask them to render, this is like that atomic pool API and stuff like that. So you can ask them to, okay, show me only the name, or show me only like the name, age and vehicles, and or even like things like show me the name, age, and from the vehicles, I'm only interested on the type and stuff like that. So we can wrap our heads around data. It's also support things like this, where you can ask the system to show me name, age, and for vehicles, just show me what keys it has. So I can keep like building my queries. In this case, vehicles are vehicles with type, wheels, and seats, and other with just types and wheels. And yeah, if you are like, even for the infinite trips things, you can say like, I'm interested only on the trips, and inside them only on the destination, and only on the expensive, and I only want to see the price. And you can run that, and it's gonna only show like the first one doesn't have any trips, the other one has a trip, and it has been truncated because it's infinite. And yeah, but you can get a look at the price of the expenses, and instead of like being lost in all that noise. Okay, for the last part of the demo, I wanted to support data windows support real-time visualization. So you can create data windows with a function. So you have already these data windows here, but you can create more. So let's create a data windows called like a changing long or something that starts up in 0. Okay. And we have a command to send a new value to a data window. In this case, it's data window value update. And if we do that, the value is going to change. But we can do like, let's try like a very simple example, which is let's make start a thread that is going to change this value very fast, following a sine wave. and you can see the value changing there like crazy. But we can look at it like this, but we can also use other tools like the scope tool that allows us to look at this in a more graphical way. Also, it's going to work if it's, I don't know, gets smaller or something, it's in real time. So it allows us to understand values in real time. Let's interrupt this thread. We are done there. For the final example, yeah, I don't know how many people remember about like the ants demo, ants colony simulator that Rich Hickey, when Clojure first came out, Rich Hickey sent this ants colony simulator showing like different things like using Clojure agents and all that stuff. And I thought it would be fine to make a demo of how I could use like something like a data window to, I don't know, look at this system. We can start the simulator here. This is the original simulator. We can run it. So it so ants start doing their thing there, and now we can, for example, I don't know, grab one ant. I will grab one ant from there, and dump ants, as you can see, are, if you look at them here, ants are represented by Clojure agents. And since Clojure agents support watches, I created a little function here to, like, whatever ants I grab it, I want to watch them with data windows. So it's going to create a couple of data windows for us. One is going to track the ant. They are showing which direction it's currently coming, and if it has some food, it doesn't currently. And I also want to graph the distance from home, which is whatever ant we are looking at, it has a distance from home. And this is nice for maybe debugging purposes, because you can look at how, like, I don't know, when an ant has food, if it start going forward home or stuff like that. And yeah, that's basically, let me stop the system, and we can get rid of this. And yeah, that's all I wanted to show you about data windows. And I think, yeah, that was it. I hope people find this that's useful. And yeah, questions?